So I'm going to show you the basic operations of Git, and there's quite a bit of information that I'm going to be leaving out, but there are many good online resources to help fill in the gaps. So I'm going to be using Git from the command line in this video because many developers prefer to use it that way. In the next video, I'll use a graphical user interface, Git client, but I do want you to have some experience using the command line because you may join a team that uses the command line exclusively. The word Git is a pejorative in many English-speaking cultures, equivalent to like idiot or buffoon. So in my opinion, it's not a great name for a tool, but it looks like it's here to stay. Git provides a way to manage the branching and merging of a team's work back into a single shared repository. The master branch always holds the latest and greatest code and is usually the starting point for any new work. Here, the master branch is the one in the center, and the feature branches extend out from it. So it's not unusual for a version control system to provide a graphical view of your system like this. So Git is not the only distributed version control system. There are some others. Mercurial is the name of one that's very similar to Git, but it's a bit less popular. Now, if you have a Mac and have installed Xcode, then Git is likely already installed. You will not have to download anything for the command line tutorial in this video. If you're a Windows person and you don't have Git installed, you're going to go to the Git website and follow the download instructions. You can just accept all of the default settings in the installer. So this is what the Git download page looks like. Okay, just click the button here. And you might notice there's a reference over here to this book called ProGit, which if you click on this link, it will bring you to this page, and you can read the entire book right here in the browser. Okay, that's free. Now, one of the tools that comes with Windows install of Git is a tool called Git Bash, which is a command line tool for working with Git on Windows. And I'm going to be using Git Bash in this demo. When working from the command line, Windows has a different set of commands than most Unix machines. Git Bash accepts many of the Unix commands, so I'm going to be using commands like ls to list the contents of a directory instead of the Windows equivalent dir. Now, Git was developed by the creator of Linux, so you shouldn't be surprised to find that most of the information you find online is going to be geared towards Unix environments. Git Bash emulates this environment on Windows, so it's a good idea to use it. If you're working on a Mac, you don't need Git Bash. You're already working in a Unix-based operating system. All you need to do is open up the normal terminal app. So once you have the tool installed, check to make sure that the install was successful. On Windows, after you install Git, you can just type in Git Bash in the Windows search bar and then select the program. If you're a Mac, you'll just open the command prompt. Okay, from the command line in Mac or Git Bash in Windows, execute this command: git --version. This obviously will tell you what version of Git you're using. So if you see the version number of the software, then you know the software was installed correctly. If you see an error message, something went wrong. You'll have to come see me and we'll have to try and figure it out. If you're a Mac and it doesn't recognize that Git command, then you will have to go to the downloads page and get the Mac installer. Okay, now let's use Git help to see a list of common operations. Okay, so this is kind of a standard man page for the Git command. If you get stuck, you can always display this help info for some guidance. But remember, just because you're working from the command line doesn't mean you can't use your browser. Okay, so when I get stuck on the command line, what I usually do is just do a Google search for whatever I'm looking for, and I find a lot of useful information. Before we dive into Git, we should look at some configurations that can be set. For example, Git logs your name and email for every commit that you perform. Git needs to know what they are. So rather than typing in your name and email address every single time we use a Git command, we can put that information in a special configuration file that Git knows about, and then Git will use it automatically so that we don't have to manually type it in over and over. Configuration data can be stored in a file, and we can tell Git where to find this file. There are several pieces of data that you may end up putting in your config files in addition to your name and email, like you might store the location of the Git repository on GitHub. However, we're going to start by just adding our name and email address to the user level configuration file called .gitconfig. Now there are several different levels of configuration file. So the system level, what this means is these are configurations for all users of the computer. They're going to use these settings by default. These, of course, can be overridden. They're usually stored in a file called gitconfig in your etc directory. Then we have user level configurations. These are individual user configurations for all Git repos when you're logged into your computer. These are stored in a file called .gitconfig in your home directory. And most of the time this is where you're going to put your config settings, since we rarely share our computers with others. And then there's project level settings. These are settings for a specific Git repository only. These are stored in a file called config in your .git project directory. We'll see that in a moment. Now you can edit these files with a text editor, but it's probably easier to use Git to set them. So first let's see what's in the config files. And to do that we'll use the gitconfig command. So this command will list the settings for the different config files. -- system means system level, -- global means user level, -- local is for project settings. So if we say git config list for the system settings, here are a list of system settings. Don't worry if you don't understand them, that's fine. If we do the same thing for the global settings, these are again really user level settings. We'll see that it's unable to read the config file. We'll figure that out in a second. So in a fresh install, you probably won't have a config file and you'll see the same error message. And lastly, if we try and look at the local config file, again, it'll give us an error message because we're not actually in a Git repository right now. Okay, so what we need to do is we need to add some user level configuration data, in particular my name and email address. So we can do this with the gitconfig command. Remember, global really means user settings. So there's a property called username and one called email that we want to set. So I'll put in my name, my email. Okay, so now if we try and list the configurations for the global or the user level, we'll see we don't get an error message anymore. We get kind of this information that I just stored, in particular my name and email. Now if you'd like, you can actually move to your home directory and look at the contents of this file. So I can say cd to change the directory, and the tilde is a shorthand for your home directory. If you execute pwd, that prints your working directory. You'll see I'm in a folder called markm. And if we do the ls-al command, that will list the entire contents of the directory that we're in, including all the hidden files. So in a Unix environment, any file or directory that starts with a dot is considered hidden, and it typically isn't shown. When you do the ls-al, that will show all of the hidden ones. So now we see that, yeah, this file actually exists now because I set the username and email. That created the files. Okay, so if we want to look at the contents of that file, we can use our cat command. Cat is short for concatenate. It takes the contents of a file and prints it to the screen. And you can see there's a particular format for these files, and it's basically just showing my name and email. Those are the only settings so far. So the config file now has my info in it, and Git knows how to get that data. So whenever I issue a command that requires either my name or email, it's going to go to this file and pull it out. Now you may want to pause the video now and update your .config file like I just did. In fact, I suggest you pause the video several times as you're watching here and perform all the steps that I do in the tutorial on your local machine. So Git doesn't just start tracking all of the changes to all of the files on your computer after you install it. We have to tell Git where to start tracking changes, in other words, what directories, and when to take snapshots, when to commit those changes. One way to do this is to create a new directory from the command line and initialize that directory with the git init command. So now I'm in my home directory, and I'm going to create a new directory called repo1 using the command line tools. Okay, so make directory is a standard Unix command. It's going to create a directory called repo1. Okay, I want to go inside that folder. So I'm going to use cd to change directories into the new repo1. And then just to show you that it is in fact brand new and empty, I'm going to list all the contents, and you'll see there are no files or directories other than a reference to the current directory and the parent directory. Okay, lastly, I'm going to say git init, and that's going to initialize this directory as a git directory. Now, any changes to the files inside repo1 or any subdirectories inside it are going to be managed by Git. And this is possible because Git adds a hidden folder when it initializes a new directory called .git. Now you can see it using the ls command. So we'll say ls-al to list all of the contents, including anything that's hidden. And we'll see now there's this new folder called .git. Okay, there's almost never a good reason for you to edit anything in this hidden folder directly, with the exception of maybe the config file. But you certainly can take a peek inside if you'd like. So what I'm going to do is I'm going to cd into this hidden folder .git, and then I'm going to list the contents of that directory. And you can see there are some files and subfolders. So one file in particular, there's one called config, which I mentioned is a place to put local configuration settings. So what I can do is I can cat the config file, and again this sort of looks like the contents of the file that I showed before. These are configurations just for the local directory. So anything not in the .git directory are just normal files and folders. In other words, there's nothing special about anything outside of .git. We call anything outside of the .git folder the working directory or the project. All of the version control stuff that we're going to talk about lives entirely in this .git directory. And if you ever want to remove version control for any reason, all you really have to do is delete the .git folder. Everything else is just a regular file or directory, so there really isn't anything else to do. The other files in the directory will not be affected by you getting rid of .git. Now logically, you can think of the .git directory as containing two different things, this thing called a staging index or a staging area, and the Git repository. Now these hold the version control specific changes that we're going to store. We'll talk about each one of these in a moment, but first let's make our first commit. The version control systems take snapshots of code at different points in time, as I mentioned previously, and we want to add our first snapshot to be tracked by Git. Now in order to do this, I'm going to create a file, edit it, and then save the contents of that file. So I'm going to use my text editor, which I have open to the repo1 folder, and I'm going to create a new file. I'm going to call it names.txt. I'm just going to add my name to it and save. This is an example of a change set. Every time we edit or update a file and make it different from its previous version, we create a change set. And Git notices that there's a change in the working directory compared to what's stored in the repository. Of course, the repository starts out empty. So next what we have to do is tell Git to add the changes that the tool noticed to this thing called the staging index. So I'm going to say git add and a dot. The dot means to add all of the changes in the current directory to the staging index. Remember, dot is always a reference to the current directory, dot dot is a reference to the parent directory. However, this doesn't take the snapshot. Okay, well, all we've done really is move the change set from the working directory to the staging index. To take the snapshot, we're going to have to use the commit command. So let's commit the change to the repository, and we'll add a commit message at the same time. Okay, so this is like snapping a photo of the current state of the directory. Git commit is how you permanently store the changes in the staging index to the repository. The -m allows you to add a commit message or a description of the change that you're committing. This stores the change set permanently in the Git repository. So a commit message is used to log the things that have changed since the last snapshot. Someone should be able to read the log of commit messages and get an understanding of what has been happening in the development of your code. Now to view the commit log, you can use the log command. Okay, this will show you all of the commits along with the commit messages. You can see the author information, the name and email. This is of course retrieved from that global config file. You can see the date of the commit message. Each commit also has an identifier, which we call a hash. So we can use this hash to identify individual commits. Here is this particular commit's hash ID. So when specifying a hash at the command line, we don't actually have to type the whole thing. It is quite long. We can just specify the first several characters, and then Git will figure out which one we're referring to. And I'll show examples of that shortly. So Git is different from some other version control systems in that it has this staging index, or a staging area, that's used to hold changes before they're committed. Now changes move from the working directory to the staging index, and then finally to the repository. So to recap, we have this idea of a working directory. This stores your files and folders. And when asked, Git can compare what's in the working directory and compare it with what's in the repository and generate a group of changes. We call these changes the deltas or the change sets. Now a change set is just a group of operations that can be applied to one set of files to turn them into another. In this case, the changes are the operations needed to change what's in the repository to make it look like the working directory, like adding a new file with my name in it, for example. Next we have the staging index, also called the staging area. This holds change sets so that a user can pick and choose what gets put in the repository. And then finally we have the Git repository. This is the permanent record of how the changes have been added over time. The changes first have to be added to the staging index before they can be committed, and we did this with the add command. We can add and commit in a single step. I'll show you how to do that a little bit later. A developer might make 10 changes to their working copy of a repository, but decide only to commit 5 of them. So we would do this if we were working on maybe 2 things at the same time. Maybe adding a feature to the software and at the same time fixing a bug that was interfering with the development of that feature. These are really logically 2 different pieces of work, and we might want to identify them as such. So we should be able to pick and choose which changes belong to the new feature and which ones belong to the bug fix. With the staging index, we can group them separately and write different commit messages for each one. You can use the git status command to see the change sets and how they relate to the working directory, the staging index, and the repo. So first let me edit the text file here. I'm just going to add my middle name and save. Then I'm going to execute this git status command. You can see that the file has been modified in the working directory but has not been staged yet. So the red message means that there are changes in the working directory. To add the changes to the staging index, we use the add command. And now if I say git status, and now you can see that the changes have been added to the staging index but have not yet been committed. The green color means that these changes have moved to the staging index, but they're not yet part of the final repository. So to commit, we use the commit command. And now if I do git status, okay, we can see that there are no changes in the working directory or the staging index that are waiting to be committed. Okay, this means everything is now in the repository. Now if we look at the log, we can see both commits. Okay, there's the first commit of my name, and then when I added the middle name. So you could think of git status as a way to see what's inside the working directory and the staging index, and you could think of git log as a way to see what's in the repository. Okay, we're going to use these two commands quite a bit to see the state of the working directory, the staging index, and the repository. So let's add a second and a third file to this repository. I'm just going to go to my editor here, create a file called second.txt. Create another file called third.txt. Save that. Okay, now I'm going to use the git status command. Okay, and you should see that there are two untracked files. So you can add files individually by name rather than using the dot notation. Okay, now you can see there is one file with changes to be committed and one untracked file. So this is an example of picking and choosing what groups of changes we want to commit together. Okay, now we should just see the one untracked file. So let's add that one. Okay, now we have third.txt in the staging area. We can commit. We do git status. We'll see there's nothing in the working directory or the staging index. Okay, notice that Git is aware of when files change and is able to pick apart the differences between them. So the comparison of what's in the repository and what's in the working directory or the staging index happens when we issue these git commands. For example, like git status. You can limit how many of the last commits you want to see with the -n option. So if we clear, then issue the git log command with the -n, and we give a number, this shows only the last three commits. Now if we only want to see the last two, we can do that. Or if we want to just see the last one, we can use that. So git log with a -n will only show the last n commits. Now sometimes you just want the gist of the log. So there's an option called one line, which shows you a condensed view of the log. So here we see the first couple characters of the hash ID along with a summary of the commit message. There's a tool called diff that will look at two files or two different versions of the same file and highlight the differences between them. Okay, so I've made a couple changes to the file here. I replaced my middle name with my middle initial, and I added a new name to the file. I've already added and committed these changes to the repository. Now I want to actually look at the difference between a couple different versions. So I'm going to start by showing the log, and then I'm going to use the diff command to maybe start out by looking at what are the differences between the first two commits. So remember, I started with my name and then I added my middle name after. Now there's a hash ID that's associated with each one of these. So I can say git diff, and I could put in the first couple characters from these two commits, put a couple dots in between them. So this is asking for the tool to look at the differences between the first version and the second version of the file. Now, the output's a little hard to decipher here, but basically it's saying if you were to take out this line of the in the first version and replace it with that line, that's how you would go from the first version to the second version. Okay. Now maybe I want to compare the first version with the last version. Okay, so I can use diff again. This time you always start with the starting version, and now we're going to put in the ID of the last version. Okay, now remember there are 3 files in the last version, so it's showing the addition of these 2 new files. But basically it's saying take out that and replace it with this, and that's how you could get from the very first version to the very last version. Now there's an option you can use called color words, okay, which may make this a little bit easier to read. Basically, green words are additions and red words are deletions from the file. Okay, so it started out with just my name, and this is saying if you add this bit of text to that first version, that's how you could get to the final version. Branching allows you to isolate your work from the rest of the repository. Creating a branch is like creating a new working directory, staging index, and place to commit for you to experiment with the code. Any new commits in a branch are separate from any other branch. You can merge branches together to combine the new work back into the master branch. You might do this when you're trying out an implementation, but are unsure if the work you're doing is going to make it into the latest and greatest. So we can't see into the future, and we all occasionally make mistakes. So it makes sense to hold off creating a permanent record of your work on the master branch. The master branch is supposed to be the pristine version of our code. As pristine as possible anyway. Bugs, of course, can reach the master branch, but at the time we commit to it, we should not be aware of any bugs in our code. If the changes are going to make it into the latest and greatest, we need a way to merge the new work into the master branch. If not, we want to be able to abandon the branch and try again from the original starting point. So this ability to isolate one's work from everyone else's is very powerful. It's common to create a branch for every new feature you work on, every bug fix, every refactoring that you do. Again, this allows you to experiment on one activity and group all of the changes related to it in one place. Then if everything works out, you can merge the changes back into the master branch as a coherent set of related changes. Okay, so now I'm going to create a new repository and add a file with 4 names in it. And each name is going to be its own commit. So right now I'm in that repo1 folder that I created before. I'm going to cd up to the parent, that's my home folder, and I'm going to make a new directory called branch project. Okay. Then I'm going to cd into branch project, and just to prove to you that it really is a new empty one, I'll list the contents. Then I'm going to issue my git init command. That's going to initialize this directory as a git repository. And of course that's going to add a .git folder, which we can see there. Okay, now I'm going to go with my text editor, I'm going to go open this folder and start adding some text. So we'll say file, open folder. Branch project. Call this file names.txt. Okay, I'll start with my name. And now, of course, I want to add each name as a separate commit. So I'm going to go back here, add the changes, and commit. Okay, so this is what the repository looks like now. I have 4 commits, and you can see the state of each of the files at each commit point. Now Git allows you to change your working directory by moving to different branches. You think of a branch as a location that you can move to, and this will update your working directory to the tip of that branch. So if you switch to a feature branch, your working directory will change to the code that's inside that branch. In other words, your working directory always reflects what branch you're in. And you can easily switch to different branches, and the code in your working directory will always have the current state of that branch. This makes going back in time to fix a bug pretty easy. To see the branches in your project, use the git branch command. Okay, every Git project has a default branch called master, and this command shows all the branches in the project. The little star shows which branch is the currently checked out one. So to create a new branch, we're also going to use the git branch command followed by the name for the new branch. Okay, this creates a brand new branch with the name prof title to add a professional title to one of the names. However, it doesn't switch to the new branch, and I can prove that by just issuing my branch command. So now we'll see there's the master branch and there's the professional title branch, but master is still the checked out one. Now in order to switch to the branch, use the checkout command. Okay. This checks out the new branch so that all new changes will be applied to this branch. So this is what our repository looks like now. We have a new branch at the end, also known as the tip of the master branch. So since we're on a new branch, let's make some changes to the file. Okay, so you probably noticed there was a typo in there. Let me fix that. Okay, if you want to add and commit at the same time, you can do that with the commit command, but you would put in this -a along with the -m. Okay, so this adds and commits at the same time. Okay, so this is now a complete history of the files. Okay, now let's switch back to the master branch. So I'm going to start just by showing all the branches. So yep, professional title is still checked out. Now I'm going to check out the master branch. You'll see, yep, that one's the checked out one. If I look at a log, you'll see I'm missing those last 2 commits. Okay, why? Because, well, we're not in that branch anymore. We're now on the master branch, and we only had 4 commits in the master branch. If you go to the file, you see that that's changed as well. There's not the PhD anymore after the one name. So Git always changes your working directory to reflect the current branch that you're on. So let me do the reverse. Let me check out the professional title branch again. Okay. And now we get those 2 commits back because we're on the professional title branch. And more interestingly, if we look at the file, we could see that the PhD, the professional title, is back in the file. And I didn't do that myself manually. That happened automatically. Git changed the contents of the file because I changed my branch. Okay, now let's create a branch to add some middle names. So imagine that different developers were responsible for the professional title and middle names features. And they were working on these two features at exactly the same time. So to simulate this, I'm going to go back to the master branch because that's really the starting point for this new feature. Okay, to create a new branch and check it out at the same time, you can do this. Okay, here I did a git checkout, but I added this -b that says create the branch and check it out all in one step. So this new branch is called middle names. We're on the middle names branch. Okay, next I'm going to add the middle names to the file and then commit the changes. And then I'm going to have a change of heart and decide to go from middle names to middle initials, and I'll commit that change as well. Okay, and this is what the repository looks like now. To compare branches, you can use the diff command. Okay, so here's a diff of the file from the master branch to the professional title branch. So remember, Git is line oriented, so it's saying if you take out this line from the master and replace it with this one from the professional title, you'll get to the final state. Okay, we could also look at the difference between the master and the middle names branch. Again, if you take out these lines and replace them with these, you'll end up with kind of the tip of that middle names branch. Now you can also use the color words option. Okay, so this is the difference in the middle names branch where anything in green is added, anything in red will be deleted. So for example, now we're comparing the master branch with the professional title, and what this is saying is if you delete this and replace it with that, that's how you get to the final state. Okay, so a branch is really just a set of continuous changes that, when applied in order, will create a working directory in a known state. And when you switch branches, your working directory has to be mostly clean. There shouldn't be any deltas that are uncommitted. So in other words, if there are a set of changes in the working directory and you attempt to switch to, let's say, the master branch, you could lose those latest changes since they haven't been committed. This is because when you switch branches, your working directory is always updated to the tip of the branch that you're moving to. So if you try and do this, Git will give you an error message. So for now, just remember, you should commit your changes before you switch to a different branch. There's a permanent reference in Git called the head. You can think of this as a pointer to a commit. The head points to a commit of the checked out branch, and it defaults to the tip of the checked out branch. So here's an image of a branch, and the head points to the latest commit in professional title. All new commits have head as the parent, and after a new commit is created, Git moves the head to the latest commit. Now when you check out a branch, the head automatically moves to the tip of the branch, or the last commit in the branch. Okay, you can't check out individual commits using a hash as an ID instead of a branch name, and this moves the head to something other than the tip of the branch. So let's check out the version of names that has the PHB error in it. So first we'll take a look at my branches. I want to check out the professional title branch. Okay, because I know that's the branch that has that particular change. Take a look at the commits. I know that error was added here. That was the first commit in the professional title branch. So what I'm going to do now is I'm going to check out that particular commit. Okay, and the way I do that is I use the hash ID to identify which individual commit that I want to check out. Okay, now you'll see I have this error message just talking about a detached head. We'll come back to that in a second. But finally, let me just do the get branch command. And again, we'll see that detached head. Okay, so what's interesting about this is I checked out that particular commit, and if you look at the editor, you'll see, yeah, my editor has gone back to that previous state. I have the PHB now. So when you do this, we are in this state called the detached head state. And when you're in a detached head state, you really should not commit, because this would cause there to be two endpoints in a single branch. So all new commits have head as the parent. So in this case, one commit could have two children. But that's not the way it's supposed to be. All branches should have commits in a row, one after the other. So one parent and at most one child. If we committed in this situation, we would have two endpoints on the branch. And if someone were to check out that branch, it would be unclear which commit to make the head refer to. So typically, we only check out individual commits when we want to read the code but not edit it. For example, if you want to build or compile a previous version of your code, you could check out a particular commit and build that version without editing any files. If you really want to write code, though, from a particular commit, what you need to do is create a new branch from that commit. So I think that's what I'll do next. I'll create a branch from that PHB error. And that's what I'm going to call the branch, PHB branch. And then I'm going to put that same hash ID in there. Okay, and I'm going to check it out. Okay, so now I could write some code and build off that particular commit. And this is exactly what you would do if you wanted to fix a bug in a previous version of the code. You go find the particular commit, create a branch that comes off it, you fix the error, and then merge that new branch into your current branches. Okay, so this is different than being in the detached head state because there is a new branch and any new commits are going to hang off the new branch rather than be stuck in the professional title branch. Okay, so here's an image of maybe if I did add some commits to this new branch, this is what it would look like. So you can create a branch from any commit point, but remember that by default you're going to get placed at the tip of a branch when you check it out. If you actually want to go somewhere other than the tip of the branch, you have to manually do what I just did here. So merging is the process of taking changes from one branch and incorporating them into another. When there are multiple change sets in each of the branches that are being merged together, each change set is either automatically mergeable by Git or requires a manual merge by the developers of each branch. So if the changes from both branches are on completely different lines in the files, then Git can combine the code automatically without human intervention. So if Bob was working on lines 800 to 850 and Alice was working on lines 100 to 150, then there's not any risk of those changes interfering with each other. Git will just add both sets of changes automatically to the file. If two change sets do affect the same line, then Git will add the code from each into the file with special markers, and then ask you to manually determine what's the best combination of the code. Now, once you've edited this marked up code, you can commit the changes, and then this resolves the merge. So let's merge our two branches together into the master branch, the professional title and the middle names branches. So we'll start with the professional title branch. Let's first take a look at the differences between the two branches. Okay, so remember here we had one line that was affected. And here we saw that every line was affected. Okay, to merge the branches together, first we have to check out the receiving branch. So we want all the changes to be merged into the master branch, so we're going to check that out. So now merge the two branches together with the git merge command specifying which branch to merge into the checked out branch. Okay, so this is an automatic merge because at the time of the merge there were no changes made to the branch that was used as the starting point for the new branch. The master branch was unchanged from the professional title branch point. The new commit is now the head of the master branch, and this is called a simple fast forward merge. The commits in the other branch will be appended to the checked out branch in all fast forward merges. Okay, so that was easy. Now let's merge in the middle names branch. The master branch has changed since the middle names branch was created because of that merge of the professional title that we just did. So this merge isn't going to be quite as simple. In any merge, if there are changes to the branch used as the starting point for the new branch, in this case master, and you try to merge back into the branch, then there is the possibility that there are some conflicts that need to be resolved. A conflict is when two different branches have changes on the same line. Then someone needs to decide which changes should stick. Now, oftentimes this will result in both sets of changes staying, but we want to make sure the conflicting changes make sense together. So these conflicts need to be resolved by a human being. Remember, there's no way for a tool to know how Bob's code should interact with Sally's. Only they can figure that out together. So if we try and merge the middle names branch into the master branch, we can no longer just add the change sets to the end of the master like we did before, because the professional title changes have already been merged in. So there's going to be a conflict on the line with the middle initial and the professional title. Okay, the developers of each branch have to work together to come up with the correct text for that one line, which it's pretty obvious for us just looking at the code what it should be. But again, the tool would have no idea how to combine these together. So when we attempt to merge this time, Git's going to add both of those lines and then possibly some surrounding lines to the file, and then it's going to ask us to fix the conflicts. Okay, so we're on the master branch. Let's take a look at the difference between the master and the middle names branch. Okay. And the thing to notice here is there's one line that has changes from the professional title branch and changes from the middle name branch. That's the line with my name on it. Okay, and this is a conflict. So let's try and merge. We're already in the master branch, so we're going to merge in the middle names branch. Oh, and we get this error message, okay, that asks the developer to go and resolve the conflicts that were found. And then once we have resolved them, to commit the changes. Okay, so it's going to go ahead and add both sets of conflicting changes to the file and then ask us to edit the file to our liking. So if you go to the editor now, the file has changed. Okay, and Git has added these special markers. So you see all these less thans, greater thans, and equal signs. Those were added by Git, and it's up to us now to look at these two changes and figure out what's the best combination of middle name and professional title. Okay, so I can kind of see here what I want to do is I want to grab the professional title, and I'm just going to tack it onto this line here. And then I'm going to clean up the rest. I don't need that entire set of changes or that anymore. So I'm going to save this. This is now the combined middle names and professional title. And I just need to add those changes and commit. Okay, and I'll do this in a single step. Okay, the new commit is the new head of the master branch. So if at any time in the merging process, if you'd rather stop and go back to the state before you even began the merge, you can actually abort the merge. Okay, I'm not going to do it here because the merge was successful, but if you ask Git to combine two branches together and you can't quite figure out how to merge them together, you can always just abort, and this will go back to the previous state. Okay, also you want to make sure your working directory is clean before you do a merge. You don't want to have any changes lying around because, again, our head is going to move and we could lose those changes. So to recap, branching and merging makes it easy for teams to focus on their features and not have to worry about interfering with each other. The separate teams can work from a common master repository and work concurrently without having to worry about merging and changes until they're absolutely ready. So on a very large team, there are people who have the job of bringing together all the different branches to prepare for a release. And the job titles for these people are usually something like configuration manager, something like that. And they're quite important non-coding jobs for computer scientists. On a small team, it's expected that everyone's going to help manage the build of a product. So you really should be familiar with at least the basics of this process. So there's a typical workflow with any version control system. You create new files, you make changes to existing files, you save those changes, you test your code. In other words, you code like normal. But then at important milestones, like the completion of some or all of your work, you add the change sets you want to go into the next commit into the staging index. And then you commit those changes with a commit message, and you repeat. So as a professional developer, this is what you do several times a day. In addition, occasionally when you've completed a feature, you're going to merge your changes into the master branch. And when you go to work on the next feature, you're going to create a brand new branch from the master. And this time the master may have more features in it from other developers who've merged them in. And you begin the whole process over again. So you're always adding your code to the latest and greatest. Okay, so let me cover a few additional useful things. First, let's talk about file operations and how they work in Git. So Git ensures that we will always be able to recreate the state of a group of files at a commit point. Sometimes, though, we delete files, or we move them, or we rename them. We have to treat these operations with care since we want to be able to go back to a repository exactly as it was at a point in time. Now, Git has special operations for deleting, moving, and renaming files. Okay, I'm going to start by going back to my previous repo. I'm going to go up and back to repo 1. I'm going to list the contents. You see there's 3 files. Let me show you this in the editor. Okay, so here are the 3 files in the editor. Now to remove a file from the repository, we're going to use a special git command. Okay, we're going to get rid of the second file. Okay, and if I do an ls, you'll see, yeah, that file really is gone. Okay, and if you look at the editor, yep, second.txt is not there anymore. So this removes the file from a working directory and moves the request to delete the file control to the staging index. So there's not really any need to do a git add whenever you do one of these file operations. If we do a git status, we'll see that that change has already been added to the staging area, and now we just have to commit. Okay, so this removes the file from the working directory and stops it from being tracked in the system. Of course, the history of that file is still in the version control system. We can always recreate it by going back in time, so it's gone, but it's not forgotten. So this is the difference between git remove and a regular remove. Okay, so let's actually go and go back a version and see second.txt back in the editor. Okay, I'm in that detached head state. But we'll see now when I go to the editor, yeah, second.txt is back. Okay, to rename a file, you use the git move command. And move is a lot like the typical Unix move. It can be used to both move files and rename them. So the move command gets added also to the staging index, which needs to be committed. So I'm going to say git move. Okay, so I'm sure that misspelled file has been bothering you for a while. Well, now it's fixed. So next you might be wondering how to recover if you make a mistake in Git. In other words, how do you undo certain Git commands? Well, to undo a change in your working directory, you can use the checkout command. So let's go here to this file, third.txt, and I'll add some dumb change here. And I'll save it. Now this dumb change has no effect on the staging index or the repository. Right now it's only a change in your working directory. Now we can throw out that dumb change and go back to the repository version using git checkout. And if we go back to the editor, we see that dumb change has been removed. So the double dash in the command says to stay on the current branch, but basically go back to the repository version of the file third.txt. So when would you do this? You would only do this when you want your working directory to go back to the stay of the repository and you haven't staged any changes. All the working directory change sets will be lost. You can unstage a set of changes using the reset command. And you would do this when putting together a commit and you decide you want to leave some staged changes out of the commit. So let me go back to this file here and add some more dumb changes. I'll save that. And then I'll start to go through the commit process. So if we look at the status, we'll say, yep, there's a change here we need to add. Okay, so that change is in the staging area. If now I change my mind and I want to remove that from the staging area, I can use reset. And we're back to where we were before. Okay, so this moves the change from the staging index back to the working directory. When would you do this? Well, you would do this when you accidentally stage some changes for a commit, but you changed your mind and you want to unstage them. Since the whole point of a version control system is to preserve the history of a set of files, it turns out it's actually pretty difficult to completely undo a commit in the distant past to remove it from the record. So each commit builds on the previous commit, so this makes true undoing impossible. However, we can always change the last commit since nothing is dependent on it yet. And there are two options. We can add more changes to the last commit. They, of course, will have to be staged first. We can also change the last commit message. Okay, so what I'm going to do is I'm going to go to this file here and make some changes, and then I want to add them to the last commit. The last valid commit that we did was fixing the misspelled file name. So I'll add some changes, save, go here. Let's first look at the log. Yep, the last one is we're going to fix the misspellings. If we see, yep, third.txt has been modified. I added that little bit of text to it. So I'm going to add the changes to the staging area. And then I'm going to git commit. This time, though, I'm going to use the amend option. Okay, and you can see the last two commits have kind of been combined into one. So the hash will change when you commit using the amend option. So when would you do this? You would do this if you want to either change the commit message because you don't like the last commit message, or if you actually wanted to add some staged changes to the last commit only. If you do want to revert the repository to a previous state, you'd use the revert option. So this is not really an undo because it creates a brand new commit from one point to another with all of the additions turned into deletes and all the deletes turned into additions. So it basically takes every change set and turns it into its inverse to put the files back to its previous state. So it's as if a person manually removed all the code that was added from the starting point and then added all the code that was deleted. And all of these changes will be stored in a new commit. Okay, so I'm going to go to the file here and I'm just going to add a word and I'm going to delete another word. Okay, I'm going to save that and now I'm going to commit. Okay, remember I have to add the changes to the staging area first. So I added a new word and deleted the word third. Okay, so now we can see there is in fact the new commit here. Now what I want to do is I basically want to revert those changes. I want to go back to the state where we didn't have that new word and the deleted third. So I'm going to git revert. I'm going to revert to the previous version that was good. Okay, so you do have to use this no commit option. So when would you do this? You would do this when you want to go back to a previous version, but you don't want to lose that history. This will kind of act like a robotic undo machine, doing the complete opposite of all the changes to back you up to a previous state. So some files we don't want tracked under version control. So we track our source code, but we don't really need to track our executables since they can easily be recreated from the source code. In fact, it's safer to use source code to rebuild a previous version than trying to store all the old executables around in the version control system. So sometimes the compiled output of a program depends on the platform or the compiler that we're using, and we wouldn't want to store the, say, like a Windows executable version of a C program because it wouldn't run on a Mac. So typically what we do is we only store the source code in the version control system, not executables. Other times we have log files or other files that we don't really care about keeping a deep history of, and we would want to ignore these files. So you can add a special file to your project to tell Git which files to ignore. Now the file has to be called .gitignore, and it has to be stored in the same place where your .git folder is. In other words, the project folder. So I'm going to go here and create my gitignore. Okay. And what this says is we don't care about this file, tempfile.txt. Git will just ignore that. And Git will ignore everything in this folder called images. And Git will ignore anything that ends with these extensions. and this will ignore any log file that has a kind of an extension with a numeric digit in it. Okay, so that's my brief overview of Git. In the next video, we'll talk about using Git and GitHub together.